Hello. So this is my next example regarding to the solution of differential equation. Actually, last class, I think we have seen the uh, solving exact differential equation. You know the concepts of exact differential equation. Okay, now let's try to see uh, what are the criteria in order to say a differential equation is said to be non-exact, and how we can solve such types of an exact differential equation. Look here, we have an equation which can be expressed in the forms of e to the power of y, e raised to 2 times y minus 3x squared plus 1 dy minus x dx. So as usual, let us try to split this one, which means let us try to find, or let us try to take off the m of xy. Actually, in the first episode, we have seen that how we can take off the m of xy dx and n of xy dy, which is minus x, and here n of xy, which is equal to e raised to 2y minus 3x squared plus 1. Now let us check its exactness, that is the partial derivative of m with respect to x, the partial derivative of m, with respect to y, which is 0, and the partial derivative of n with respect to x. This one is 0, this one is 0, which is minus 6x. Look here, m sub y, which is the partial derivative of m with respect to y, is not equal to n sub x, which is the partial derivative of n with respect to x, because here there is not equal to what? There is not equal to negative 6x. So now what we can do? So if it is not exact, look, not exact. So now let us try to find an integrating factors. Mu of xy, such that if we can multiply this equation by this integrating factor, it should be automatically become what? Exact. So now how we can find the mu of xy, or how we can find the integrating factors? So now here we have several methods. That is, the first method is if now let us check one by one. N sub x minus m sub y over m is independence of x. Look, if the partial derivative of n with respect to x minus the partial derivative of m with respect to y over m is independence of x, if is independent or free of x, now our integrating factor mu should be e the power of n sub x minus m sub y over m dy. This is our integrating factors. Now let us check whether this one is independence of x or not. Actually. Here n sub x is this one, negative 6x minus m sub y is this one, 0 over m is minus 6, which is 6, independent of x, Now here our integrating factor is mu of xy, or simply mu, which is equal to e the power of is the power of minus 6x minus 0 over minus x. Sorry about this one. This one is minus x. Minus minus should be plus x. Plus x dy, which is equal to you know, actually here. So here our integrating, if it is independent of x, our integrating factor is mu of y. If it is independent of y, our integrating factor is mu of x. So now here we have mu of y. Look, is a power of, actually this one is already 6. Here we have an integral over there, integral dy, which is equal to is a power of 6y. This is an integrating factors. Now simply we can multiply both sides by this one. Actually, before that, now we have Roman number 2, which is the partial derivative of m with respect to y minus n sub y over n is free of y. Is free of y. Again, we have an integrating factor mu, which is equal to is a power of integral of m sub y minus n sub x over n dx. This one is dy because here simply it's independence or free of x. For the other case, we have actually d of y. So actually, if possible, we will try today, and I will try to do another example regarding to this one. So now let's multiply both sides by this one. You know, both sides by this one, and after that, checking if its exactness, and then we'll proceed to what, the next concepts. So now let's multiply e the power of 6y times minus x dx plus e the power of 2y minus 3x squared plus 1 dy. Now let us put this one in the plus. Okay, now let us check it. It should become minus x is the power of 6y dx plus, again, it should become is the power of 8y. You can multiply this one minus is the power of 6y 3x squared plus is the power of 6y, again dy is equal to 0. Now let us check its exactness, which means m sub y, which is equal to the partial derivative of m of x with respect to 1. Actually, this one is 0. This one is negative 6x is a power of 6y and n sub x, which is equal to, this is 0, this is 0. Simply this one is 0 because with respect to this, minus 6x is a power of 6y. Here m sub y is equal to n sub x. It become what, it become exact. Now what you can do, if it's exact, we have the solution, that is u of x y, which is equal to u of x y, which is equal to integral of m of x y dx plus simply g of y. Now here we have integral of what's m. M is this one, negative x is the power of 6y dx plus g of y. let us integrate this one. Let us integrate this one. Because simply takes this one as a constant. Now it should become negative 1/2. Look, simply it should become negative 1/2 x squared times the power of 6y plus what g of y. This is our solution. Now the question is finding g of y. Simply here we'll try to differentiate u of xy in the integral of m of xy dx plus g of y with respect to y. Then it should become, look, it should become the partial derivative of u with respect to y is equal to the partial derivative of negative 1/2 x squared times e to the power of 6y with respect to y plus g prime of y, because the partial derivative of g of y with respect to y is g prime of y. Now let's find this one. Actually this is n of xy from the first episode. We know that this one is n of xy. So now what we have actually this one. Look, we have the partial derivative of u with respect to y equal to the partial derivative of negative 1/2 x squared times e to the power of 6y with respect to y plus g prime of y. Now this one is actually n of xy. You know, n of xy is here, which is 8. E to the power of 8y minus e to the power of 6y 3x squared plus e to the power of 6y. This one is n of xy. N of xy is equal to. Now let us find the partial derivative of this one with respect to. Actually this is constant. It should become I think it should become 6 times negative 1/2 x squared times e to the power of 6y plus g prime of y. Now actually this should be cancelled by this one because it becomes 3. Now let us rewrite it again for a more clear way. Minus e to the power of 6y 3x squared plus e to the power of 6y is equal to, this one is negative 3x squared e to the power of 6y plus g prime of y. Look, should be cancelled by this one actually, which what we have, g prime of y equal to e to the power of 8y plus e to the power of 6y. Now let us integrate. It should become, this one is actually g of y. It should become 1/8 is the power of 8y plus 1/6 is the power of 6y plus certain constant c. See? Now let us substitute this one in our solution. Here our solution is u of xy, which is equal to negative 1/2x squared is the power of 6y plus g of y. G of y is here, which is equal to negative 1 over 2x squared is a power of 6y plus g of y is 1 over 8 is a power of 8y plus 1 over 6 is a power of 6y plus what we have, let it be c. Now simply take c is equal to 0. Take c is equal to 0. What we have 1 negative 1 over 2 x squared is a power of 6y plus 1 over 8 is a power of 8y plus 1 over 6 is a power of 6y. Let it be equal to c1 is the general solution. Here our differential equation is not exact. Here we are expected to find what, an integrating factor. If it's exact, simply we have to apply the formula, which is u of xy equal to integral of m of xy dx plus g of y, and then finding simply g of y, and then substitute. If it's not exact, we have expected to find so-called known as unintegrating factors. Unintegrating factor is usually expressed in the form of what, mu of xy. This one is actually integrating factor. Usually it is expressed mu of xy. If we can multiply the differential equation by such integrating factor, it should become what, exact. Now the point is how to find an integrating factors. Look, so here to find integrating factors, we have used so-called known as the elementary integrating factors. Actually, this is in short IF. The first one is if m sub y, which means the partial derivative of m with respect to y minus n sub x, the partial derivative of n with respect to x over n is free of y. Look, free of y. Then our integrating factor is u of x, which is equal to e the power of integral of m sub y minus n sub x over n dx. This is the first case. The second one is if n sub x minus m sub y over m is free of x, now we have an integrating factor mu of y become is a power of integral of n sub x minus m sub y over m dy. After finding integrating factor, simply we have multiply our differential equation by one of those integrating factors. Actually, this one is elementary integrating factors, and then it should become the exact differential equation. After we check whether the DE is exact or not, simply we have to apply the formula, which is u of xy, which is equal to integral of m of xy dx plus what we have, the g of y. Then, as usual, here we'll try to find g of y. In order to find the g of y, simply after integrating m of xy with respect to x, or m of xy dx, simply we have to take the partial derivative of both sides with respect to y. That is the partial derivative of u of xy with respect to y equal to the partial derivative of integral of m of xy dx with respect to y plus the partial derivative of g of y with respect to y. Then what we have get g prime of y equal to the partial derivative of u with respect to y is n of xy. N of xy minus integral the partial derivative of integral of m of xy dx with respect to y. This is simply the solution of exact differential equation. Actually, in another video, I will show you how to find the solution of another several types of differential equation. Thank you for your watching. Please subscribe my channels and put your comment on the comment box for further improvement. Thank you.